This is day 19 of Advent of Code 2024 Done and Go. This challenge is called Linen Layout. Today, the historians take you up to the hot springs on Gear Island. Very suspiciously, absolutely nothing goes wrong as they begin their careful search of the vast field of helices. Could this finally be your chance to visit the onsen next door? Only one way to find out. After a brief conversation with the reception staff at the onsen front desk, you discover that you don't have the right kind of money to pay the admission fee. However, before you can leave, the staff get your attention. Apparently, they've heard about how you helped at the hot springs, and they're willing to make a deal. If you can simply help them arrange the towels, they'll let you in for free. Every towel at this onsen is marked with a pattern of coloured stripes. There are only a few patterns, but for any particular pattern, the staff can get you as many towels with that pattern as you need. Each stripe can be white, blue, black, red, or green. So a towel with the pattern GGR would have a green stripe, and then a red stripe, in that order. You can't reverse a pattern by flipping a towel upside down, as that would cause the onsen logo to face the wrong way. The official onsen branding expert has produced a list of designs, each a long sequence of stripe colours that they would like to be able to display. You can use any towels you want, but all of the towel's stripes must exactly match the desired design. So to display the design RGRGR, you could use two RG towels and then an R towel, an RGR towel and then a GR towel, or even a single massive RGR towel, assuming such towel patterns were actually available. To start, collect together all of the available towel patterns and the list of desired designs, the puzzle input. So this first line indicates the available towel patterns. In this example, the onsen has unlimited towels with a single red, unlimited with a white and a red, and so on. After the blank line, the remaining lines each describe a design the onsen would like to be able to display. In this example, the first design, BRWRR, indicates that the onsen would like to display a black stripe, a red stripe, a white stripe, and then two red stripes in that order. Not all designs will be possible with the available towels. In the above example, the designs are possible or impossible as follows. BRWBR can be made BR, WR, then R, and so on. I think we get the point of how this works. So in this, there are a total of 6 of 8 designs which are possible. So to get into the onsen as soon as possible, how many designs are possible? Okay, so let's get started. Okay, so we'll first grab the test example because we know what the output of that would be. So we have this. We need to we'll first split on new line. So we have this and this. Then we could do towels. This can be, I'll just do a list of string. Then we do for towel in range lines 0, and that should be strings.split, and that will be a split on comma space. We then have the towel, and we do towels equals append towels towel. And what's wrong with this? Oh, yep, that's right. So we've got our towels. Okay, well, it's giving a suggestion for what I should do, and yes, I should do that. Although, okay, we will do that. We'll grab that, do this, and then spread it. And I guess we could go a step further and just do this, right? Okay, maybe not. But let's format up print. Make sure we've got all the towels in here. Okay, that's the towel sorted. Now we need to go for the patterns. So patterns, same thing again, basically, except for this one. It will be, might be the same thing again, but this will be 1 and split on new line. So now let's print out patterns. Okay, that didn't work because I did the wrong list. That one seemed to have worked, or did it? Let's do patterns, length of patterns. So I did it out. I was expecting to see a comma within it, but maybe, okay, yeah, that's fine. Cool. So we first would go over the patterns, then, okay, we've got this. Now I need to figure out, it would be, okay, so we need to make sure that each thing can go into it. But then there are things like, let's say for this one, B could just go onto it, BR could, I guess, go into it. Okay, so we'll need to go over, okay, I just had a thought, so we have the pattern. We could iterate over it up. So I was originally going to go, okay, we look at this and see if that exists here, if this exists here, so on. But no, we start with the pattern itself and go, do you exist in here? Do you exist in here? So to do that, I would instead change towels to a map. So make map and string, I'll do bool. And for tau in range of this, we then do tau equals true. And then we can use that to go, okay, if pattern in taus, if it doesn't exist, it will return false, otherwise it would return true. So there's a few things which I'm trying to figure out. So what if, say for example, there was B, there was BR, then there was RW. So B could go here, BR could go here, then but RW could go there. What if there was no W by itself, just B, BR, then RW? So if we did BR first, we'd be stuck with B, but we don't have a B by itself, W by itself. So we'd have to do B and then RW. So that's something I'm trying to figure out how we would make sure that doesn't become an issue, but I'm not sure how. Okay, so maybe instead of, normally with these things you start with like this position, and then you kind of look forward. Maybe we start here, and then we look backwards. Maybe. So we'd start off with B. Is that covered? Yes. We'll then go to R. Is that covered? Yes. Go to W, and kind of... Okay, we'll try that. So we'll start off with the loop here for I. I going to equal 1 or 0. Okay, so we'll be using slices to look this up. So this will start as 1, but it's actually going to be 0. So it's let me just write it out. So I is less than or equal to length of pattern I plus plus. So we do this, but then we do for j is equal to, and this one will be 0. J and this one will be less than I, and then j plus plus. So, although for this to work, we need to keep track of which ones we've already looked at, and we need to be able to say that yes, the previous ones we've looked at do have tails that match it. So I guess matches. This will be an int. Oh, not an int. It's an int map. We make map int and bool. No, it doesn't need to be. No, this just needs to be a bool array. We make it the length of the pattern. So we've got matches. Just thinking what numbers we need for this. I think it needs to be also first if pattern j wait, okay, so ji pattern ji, if that exists in taus, then matches, so that wouldn't be j, that would be I, which works. Yeah, so this would be matches I, although we've done starting. Okay, so need to do a plus one here, make this true. So because this is up to a point, but then we are doing matches without first. So when we're looking at the substring, which does extend to the next one, we need to make sure the starting point is a match as well. So you can't just have a substring within the whole pattern. So we need to do matches j and taus. Okay, well we now need to initialize 0 for this to equal true. So we found our match on the current number. We then break from it because we're no longer looking at this position. So with this one, let's say there's let's say BR. Let's say this B wasn't here. Actually, well, so we know BR. We will go to say 2, start on 0. Okay, no, that does work. Yes. We would then go to here. So if we start on this one, we would find nothing that leads up to it, which would do it. We then go to here, and we will get to this point, and it's from that point forward. So these two. So that one's true, but then we'll go from there to there, and it would work. So I think this is working, and so we're having these saved. So then I think it would be if matches length of pattern, then output plus plus. Let's try that. Okay, we've got 6. That is promising. So then let's try it on the real one. 216. Let's try you. And that was correct. So let's now go on to part 2. The staff don't really like some of the tile arrangements you came up with. To avoid an endless cycle of tile rearrangement, you should just give them every possible option. Here are all of the different ways the above examples designs can be made. BRWR can be made in 3 different ways. BGGR can only be made with these ones. And this one can be made in 4 ways. And then this one can be made in 6 ways. And so on. Coming to a total of this. Interesting. Okay, so we need to change how this works, so we try and record every possible option. Okay, so we can't just do booleans now for checking. We would have to keep track of the numbers. So maybe int 1. So there's one way to do an empty, I guess. And then this would be... Ooh. Okay, so if matches J, that means we have reached that point. We're now recording the numbers, so it's how many ways we've reached this number is the same amount of ways to reach this number. So plus equals this, and remove this. If this is greater than 0 will do. So in our current position, and by looking backwards, there might be multiple different ways we can get to this current point. And each time we find that way, we're doing plus equals the previous numbers of ways to get to that got to there. So if we switch back to the easier one, let's see, so we start off, let's say 0 is 1, we then go to here, and so it starts off with just B. We go to here, we look back, and there's BR. Okay, now this is 1, but also this one can be done by itself, so we could also go to here and do just R, so now this would be a 2. And then we go to here, there's currently no way to get to here, so this would be a 0. We'd go to this next one, and we would look back. Okay, so this one has 0, we can't do R. We look back to here. Okay, there were 2 ways to get to there, and this one matches, so now it is 2 to get to here. And then here would be just an R, so then, but it would look back, so that'll be 2. Actually, I should check, was that how it worked? Which example? Yes, so that is how it works. So let's run it and see. Okay, so this one needs to be if matches length pattern. This just needs to be output plus equals this. Which if it's a 0, then that's fine. So I've now got that. Let's rerun it. That was a lot larger of a number than I thought it would be, but maybe that's right. Wow, okay. Well, that is right. So, if you like this video, make sure to like and subscribe.